Okay, Assalamualaikum warahmatullahi wabarakatuh. In this video, I will explain the chemistry worksheet that you have sent me. I will try to explain some questions, and in our direct session, we will try to understand the rest of the questions. Okay, so I will just explain the questions from the beginning. Let's take a look at the first question now. So the first question says, let me just remain this right. So here, if you look at the first question, it says, which change to an atom occurs when it forms a positive ion? So this is very easy question, right? So here you should underline the keywords. So what is the change? So we have to underline the change that happens when an atom produces a positive ion, right? So we know that from an atom, we can produce ions, right? So ions. So we have two types of ions. They are positive and negative, right? So positive ions are called cation and negative ions are called anions, right? So let me take this as cation, right? And we haven't talked about anions in this question. So let me skip that part. So positive ions mean that is cation, right? So for example, metals can produce cations. So for example, if we take a typical example, sodium is an atom. So if we want to produce sodium cation, the sodium should lose one electron from its outer shell, right? So sodium plus is produced by removing one electron from the outermost shell of sodium atom, right? So here you just look at the answers. It gains electron. No, if an atom gains electron, it will produce anion, right? So it will produce anion. So this cannot be the answer. It gains protons. No. Only electrons can be gained or lost from an atom, right? So no, protons, this cannot be the answer, definitely, right? So this also cannot be the answer. So C is the correct answer. Why? When an atom loses electrons, it will produce cation, right? So this is the answer. C is the answer for the first one. Now B part. Which changes to an atom occurs when it forms a negative ion? That is very simple, right? So we have already discussed. So the answer is A. Okay, right. Now, negative ions mean anions, right? So the name that we give for negative ion is anion, right? So you should know this. For example, chlorine, right? Cl accepts one electron because we have 7 electrons in the outermost shell of chlorine. So to satisfy octet rule, it should gain one electron. So it will gain one electron and form Cl minus ion. So this is called anion, right? Okay. Now let's look at the second question. So place a tick in one box, each row of the table to show the type of bonding for the given substance. So here in this column, they have given some substances and here type of bonding. So we have learned two types of bonds, right? So ionic bonds and covalent bonds. And here they have given another type of bond, that is metallic bond. So this metallic bond exists in metals, right? So in metals, right? For example, if we have sodium, between sodium cations and electrons, delocalized electrons, we have a strong bond. So that is called metallic bonds, right? Okay. Now let's try to do this question. Now in nitrogens mean that is N2, right? So we have already studied, we have drawn a Lewis structure for nitrogen. So this is a diatomic molecule, right? So two atoms combine together to make a molecule. So this is called diatomic molecule. What is the name that we give for this type of molecule? Diatomic molecule, right? Right. So here we have triple bond, right? Because in the nitrogen, in the outermost shell of nitrogen, we have we have 5 electrons. So to satisfy octet rule, one nitrogen atom needs 3 electrons. So another nitrogen atom also will come and they will share their electrons. Okay, so they have 5 electrons and they will share 3 electrons to become N2 molecules, right? So if we draw a diagram, so draw diagram for this, right? So this is how it will appear, right? So this is the nucleus of those 2 nitrogen atoms, and we have the outermost shell here and the next outermost shell here, right? So I'm sorry. Right. Now, this is the nucleus, right? So if we take an individual nitrogen atom, right? So let's say this is the nucleus. We have 5 electrons, right? So 4 paired and 1 lone pair, lone electron. Now what will happen? They will share 3 electrons. So 3 electrons. So they have 3 electrons, right? 1, 2, 3, 4. Okay, now if I draw like this, it will be easier for you to understand. Okay, so let's assume an individual nitrogen atom. It has 5 electrons in its outermost shell, right? So 5 electrons, right? So I draw 2 paired and the rest 3 as single electron, right? So we have another nitrogen atom like this. Now that nitrogen atom also has 3 single electrons and 1 pair. So this is satisfied, but this and these are single, so they should be paired with another nitrogen or with another electron, so they will share these 3 electrons. So if I draw the next ion, next let me use a different color to draw that. The next nitrogen atom, it will be like this. So we have 2 paired electrons and 3 single electrons. So what will happen here? What will happen here? This and this will share. This and this will share. This and this will share. So I can either use cross or I can use different color also. So I have, okay, now this is, I have drawn these 2 electrons here, and I have to use a red color to draw these 2 electrons. Let me change the color. Right. So these are the paired electrons in the first nitrogen atom. And let me again use new blue color. Right. Now we have already drawn these 3 electrons in red color, and this electron is shared with this. So I have to draw like this, right? So here, this is the diagram for N2 molecule. So I have just explained, I have already explained these things in our previous classes also. I don't want to spend much time here. Okay, so we will go to the next one, right? Okay, B, calcium chloride. So calcium chloride means CaCl2, right? CaCl2. So here we have 2 ions, one cation and anions also. The cation is calcium 2 plus, and the anion is Cl minus. So here we have 2 plus. So to attract these 2 plus, we need two minuses. So we will have 2Cl minus, right? So here with this Cl minus and this Ca2 plus and this Cl minus and this Ca2 plus, there will be an electrostatic attraction. So that is called ionic bond. So this is ionic bond. So this is covalent bond, right? So this is covalent bond. So when electrons are shared, we say covalent bond. And when an atom is losing electrons and the lost electrons are accepted by another atom, then an ionic bond will be created. Now here calcium 2 plus removes 2 electrons, right? So this is how it happens. So I have already explained you with the example of NaCl, right? So Na reduces or Na loses 1 electron and the lost electron is accepted by Cl chlorine atom. Right here from calcium ion, from calcium atom, right? So from calcium atom, 2 electrons are lost. So 2 electrons are lost. So we have calcium atom. So from the calcium atom, 2 electrons are lost. And out of the 2 lost electrons, 1 electron is accepted by 1 chlorine atom. And then the next second electron is accepted by the second Cl atom to form calcium chloride. Now again in magnesium what happened? So magnesium is a metal. Magnesium is a metal. So in a metal, it can be an atom, we will have metallic bond. So the interaction or the strong bond between the metal ions and the delocalized electrons is called metallic bond. So here the answer is metallic bond. Now lithium is also the same case, right? So the lithium is a metal. So we will have metallic bond. And what do you think about hydrogen? So hydrogen means that is H2. So between these H2 we have already studied, right? Covalent bond. So 2 electrons are shared to form a single bond. So H2 we have a covalent bond. Then sodium fluoride. Sodium fluoride means Na plus and F minus. Na plus and F minus. So between an anion and cation, we have electrostatic forces. So that will be ionic bond. Okay. Now, this question is about substances with covalent bonds. Draw a dot and cross diagram to show the outer shells of electrons in a molecule given below. So I think we have already discussed this question. I have drawn, right? So here you have to carefully read the question. This question is about substances with covalent bonds. So all are covalent bonds. So for covalent bonds, we can draw Lewis structure. We can say, otherwise we can say dot cross diagram, right? To show their outer shell electrons. You don't need to draw all the electrons in all the orbitals. You should only draw the outer shell electrons. So O2 means, okay. So here, how O2 means there are 2 oxygen atoms. So in each oxygen atom, we have 6 electrons, right? So 6 electrons mean I will just draw like this, right? O2 and 2 are single like this we will consider. And the next one, let me use a different. Okay, I will use, because since they have asked to draw dot cross diagram, we have to use cross and dot only. We cannot use different colors or only dots. Okay. So if I denote the electrons in the second atom like this, now this is satisfied. This is also satisfied because they are paired. But here this is single, this is single. Here this is satisfied, this is satisfied, but this is single, this is also single, right? So this and this will share, and this and this will share. So what will happen? So ultimately, this is how it will be resulted. So how they have shared these 2 electrons. How? 1 dot and 1 cross. 1 dot and 1 cross. So they will form double bond. and this are there. This and this are there. So this is the cross dot diagram, and here this and this we have to separately draw like this. Okay. Now H2O. H2O we have already drawn, I think. N2 I have already explained. H2 also CO2. Okay, let me explain you the dot cross diagram for CO2 now. And I think you can try the rest by yourself. And if you struggle, you can just give me a message on WhatsApp. Otherwise, you can just try this question and send me the answer. I will correct it. Okay. Right. So CO2 means we have carbon, right? So we have one carbon and two oxygens. Two oxygens. Now in the carbon, we have 4 electrons. Okay. We have 4 electrons. And okay. So in the carbon, we have 4 electrons. In the oxygen, we have 6 electrons, right? So here you should know that carbon can make 4 bonds, right? So since we, okay, carbon can make 4 bonds, oxygen can make 2 bonds, right? So the common is 2. So between this carbon and oxygen, 2 bonds will be formed. 2 bonds will be formed. So I have to denote all the electrons in carbon as single, right? Like this. And I will denote the electrons in oxygen using cross, right? Using cross. How? Like this. As we have already drawn to for O2 molecule. Okay. We have 6 electrons here in this oxygen, and in this oxygen also we will why? So I will just draw here. Okay, using cross and drawn. So here the central atom will be carbon, right? So here this is how it will appear. Between this carbon and this oxygen, there will be 2 double bond, and between this carbon and another oxygen, there will be double bond. So two pairs of electrons are shared here. So this is how it will happen, right? So let me use a different color to denote. Now this and this will share, and this will share. Okay, so here I don't know why the annotation is disappearing here. Anyhow, okay, again, okay, so this is paired. So let me use this. This is paired, and this is also paired. Again, here this electron will be paired with this electron. This electron will be paired with this electron. So how can I draw this? So I will just draw the carbon. So the outermost shell of carbon here, and here. Okay, let me use a different color. Can easily understand. Okay, this is the outermost shell of carbon, right? And this is for oxygen, right? Oxygen. Now, all the outermost shell electrons in carbon atoms are paired with 2 electrons in the outermost shell of oxygen atom. So here here this is paired with this. So here a dot and cross, then here a dot and cross for this sharing, right? Okay. Then this and okay, I should have drawn another pair, right? Because in the outermost shell of oxygen we have 6, 1, 2, 3, 4, 5, 6. Now here I have to draw this, this. These are two paired, and again this and this. Again, now this electron is paired with this, so I will draw a dot and cross. This pair of electron is belonging to both this carbon atom and oxygen atom. This means this pair of electron belongs to this carbon atom and this oxygen atom. Again, this sharing, right? So here dot into cross. Again, you see this and this should be drawn separately on the oxygen atom. So I have to use cross, right? Cross, 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 cross. So likewise, you can try the rest of the question also. Now we will move to the fifth question. Have we discussed 4 questions so far? Yeah. 1, 2. That is the third question. Third question is missing, right? Okay, anyhow. Now we'll come to the fifth question. Now here, a metallic lattice structure is shown in the diagram. Yes, this is called the sea of electrons or ocean of electrons, right? These are delocalized electron, and these positive ions are called metal ion. For example, let's say if we have sodium, now sodium plus will be there. And why? Because sodium, okay, now if this is a sodium, let's say this is a chunk of sodium metal. Now in sodium, we will have a lot of sodium ions, right? So sodium atoms. So we will have sodium atoms. So sodium, it has extra 1 electron in the outermost shell. So to hold octet role, it will release the electron in the environment. So sodium plus will be there along with the delocalized electron. So this is removed. This electron is removed. So it will have the delocalized electron, means it can freely move. So this is delocalized electron. Okay, now let me stop here and I will discuss the fifth question in another video because I have to go somewhere. So I will just stop the video here and I will discuss the fifth question in our direct session, or I will try to upload another video. Okay.